Assalamualaikum dear learners. Today I welcome you all to the solution set of a long question of exercise 2.1. So let's start. So in question number 2, you have given the four vectors, the four vertices, the P, Q, R and S. Now you have to prove that the scalar projection of PQ on RS and the scalar projection of RS on PQ is equal. Also, the second thing you have to prove is that the angle between them is minus 4 by 9. So before proving this, we have to find PQ and RS. So PQ equals OQ minus OP. You know that the position vectors of both. Putting values here and simplifying, you will get PQ equals minus 2 to 1, means minus 2i, 2j and 2k, and RS will be equal to I minus 2j plus 2k. Okay, now you have to first find the scalar projection of PQ or RS. What is meant by scalar projection? Scalar projection is actually the shadow of PQ on RS. You will see that if there is a vector PQ, then its x component will be PQ cos theta and the y component will be P sin theta, PQ sin theta. Now you have to find the projection of PQ on RS, which is this. Okay, so what you have to find? You have to find PQ cos theta. By the definition of dot product, you know that PQ dot RS equals PQ magnitude, RS magnitude, and the cosine of angle between these two. So what you have to find? PQ cos theta. So after separating PQ cos theta here, you will get the formula PQ dot RS over RS magnitude. Now putting values here, after putting values, you see that after taking dot product you will get this, and after taking the magnitude of RS you will get the final answer as minus 4 by 3. Now what we have to find? We have to find the scalar projection of RS on PQ. So the scalar projection of RS on PQ, by the figure you see that the projection of RS on PQ is RS cos theta. So by the formula of dot product, PQ dot RS equals PQ magnitude, RS magnitude, cos of theta between them. So after simplifying this, you will get the answer minus 4 by 3. So scalar projection of PQ on RS and RS on PQ is equal. Just now going towards the second portion of this question, which is you have to prove that the cos of angle between PQ and RS is minus 4 by 9. Again you will use the formula of dot product between PQ and RS. PQ magnitude, RS magnitude, cosine of theta. The theta is the angle between PQ and RS. Now you have to find cos theta. So you will, in question number 3, you have to find a unit vector which makes an angle of 45 degree with this vector and angle of 60 degree with this vector. So let u be any unit vector. Let u be xi plus yj plus zk be any unit vector having the magnitude 1, and this is a vector. Let this is a vector 2j minus k, and let b be the vector this j minus k. Now according to the given condition, the angle between u and a is 45 degree. So you can write it like dot product u magnitude, a magnitude, and cos of theta between u and a. So what is u? U is xi plus yj plus zk, and taking dot product with the a vector 2y plus 2j minus k equals u magnitude is 1 and a magnitude is 2 square plus 2 square plus minus 1 square, and cos theta cos 45 degree. Now putting the values and solving it, you will get the equation number 1, which is 2x plus 2y minus z equal to 3 over square root 2. Now using the second condition, that is the unit vector is making an angle of 60 degree with this vector. So similarly, u dot b equals u magnitude, b magnitude, and cos of theta. Putting values and taking the dot product of u unit vector with b vector, we can get. Now after taking the dot product and the magnitude, you finally get this answer, or you can further write it as square root 2 over. In more simplified form, you can write any number in 2 times square root. So this will cancel out and 1 over square root 2. So the second equation y minus z equal to 1 over square root 2. This is equation number 2. So this is equation number 1 and equation number 2. Now there are 3 unknowns, and for equation number 3 you can use the fact that that is given that u magnitude equal to 1. What was u? U was xi plus yj plus zk. Now taking its magnitude, which is x square plus y square plus z square equals 1, or x square plus y square plus z square equal to 1. This will be equation number 3. And now separating x and y from 1 and 2 in terms of z, you can write from equation number 2, the 2 implies y minus z equal to 1 over square root 2, or you can write it as y equal 1 over square root 2 plus z. Okay, now putting this equation of y in equation number 1, which is 2x plus 2 1 over square root 2 plus z minus z equal to 3 over square root 2, inputting 1. Now simplifying it, this will be 2x plus, as I said before, that you can write it double times, square root 2 over square root 2 in more simplified form, plus 2z minus z is z equal to 3 over square root 2. This will lead to 2x plus square root 2 plus z equal to 3 over square root 2, or separating x from here. Now after simplifying and separating x from this equation, and after taking LCM, you get the final form of x in terms of z like this. Now putting this value of y and x in equation number 3, after putting values and opening the formula, we get the expression like this. Now simplifying more here and taking the LCM, after taking the LCM you will get the expression like this. Now 2z square plus 8z square plus 8z square is 18z square, and minus 2 square root 2z plus 8 square root 2z is plus 6 square root 2z, and 1 plus 4 is 5, and 8 will go here equal to 8. You will get the final form as the quadratic equation, which is 6z square plus 2 square root 2z minus 1 equal to 0. Now putting this values in quadratic equation, quadratic formula, and finding the value of z. So putting the values of coefficient in quadratic formula and solving it, you can find that the answer in simplified form can be found as like this. You can see the solution or any steps. Now putting the values of z, the first value of z in equation number 2, you will find the value of y, and in equation number 1 this will lead to the value of x. Now the u vector was xi plus yj plus zk. Now putting values in that vector, you will get 1 over 3 square root 2i plus 2 square root 2 over 3j plus 1 over 3 square root 2k. This is the vector for the value of z as 1 over 3 square root 2. Now for the value of z equal to minus 1 over square root 2, you can find the value of y and x as y will be 1 over square root 2 and x will be 0. So the unit vector will be 1 over square root 2i minus 1 over square root 2k. This was question number 3. In question number 4, you are asked that if a and b are any vectors, then show that this expression is perpendicular to this expression. Now using the fact that the two vectors will be perpendicular if the dot product is 0, now finding the dot product, you will write you can write it as a mod b and a mod dot a mod b minus b mod a, likewise plus b mod a dot product with a mod b minus b mod a. And now you can write it like a mod dot a mod is a mod square. This is the property, and this is b dot b minus a mod b mod and b dot a, plus likewise here b mod a dot b minus b mod square a dot a. Now you can write this is self product, and b dot b equals b mod square. This is the fact you can write, you can use a mod square b mod square minus these two are equal because a dot b and b dot a are equal, the commutative, minus b mod square a mod square. Now these are two are equal, the answer will be 0. Since the dot product of these two expression is 0, it means that this expression a mod b plus b mod a is perpendicular to a mod b minus b mod a. Now the question number 5 introduces the most important property of absolute values, that the absolute value of sum of two vectors is less than equal to the sum of two absolute values, and this is further is less than equal to the difference of two modes. Now proving this, you will get writing using this a plus b mod square equal a plus b dot a plus b. This is a self product as I used in the previous question. Now taking dot product here, okay, this will be like a dot b plus b dot a plus b dot b. Now the self product will be equal a mod square plus 2 times a dot b plus b mod square. You can also write it as a mod square plus 2a mod b mod cos theta plus b mod square. Now the range of cos theta is less than equal to 1. You will write it like this, plus minus 1. The range of cos theta is this. So this expression, or you can write cos theta is less than equal to plus minus 1. That is, for cos theta प्लस माइनस 1 के लेस इक्वल हो सकता है, तो हम यहाँ पे इस एक्सप्रेशन ले सकते हैं लेस देन इक्वल्स a mod square प्लस 2a mod b mod plus b mod square. Okay, now this is equal to, this is not less than, this is equal to a mod plus b mod whole square. The left hand side was a plus b mod square. This will give you a plus b mod equals a mod plus b mod. Sorry, this is less than equals a mod plus b mod. This is equation number 1. Now taking this part of the question, you can write a mod equals a plus b minus b mod. You can write it like this because plus b minus b will cancel out, and this will be equal to, using the property number 1, that a plus b mod plus minus b mod, that is the sum of two vectors, is then equal to the sum of their absolute values. This is a mod. A mod is less than equals a plus b mod, and the minus b mod will be equal to plus b mod because the absolute value of negative and positive will be equal. You can write it as a mod minus b mod less than equal a plus b mod. This is equation number 2. Now combining equation number 1 and 2, you will see that you will get the answer a minus b less than equals a plus b mod, and continuing from equation number 1, less than equals, don't forget to put vector sign here, a mod plus b mod. Hence proved. Question number 6 says, if u and v are unit vectors and theta is the angle between them, then you have to find this expression in terms of theta. You see, you can write u plus v mod square equal to u plus v dot u plus v. These u and v are unit vectors, so their magnitude will be 1. This property is also used in previous question. Now you can write u dot u plus u dot v plus v dot u plus v dot v. This is a self product and it will be equal to u mod square plus 2u dot v plus v mod square, or u mod square is 1 because this is unit vector and u mod square will be 1 plus 2 u mod v mod cos of theta plus v mod square. The v mod is 1 because this is a unit vector and the magnitude will be 1. 2 plus 2 u magnitude is 1, v magnitude is 1, and cos theta. This is u plus v mod square equals 2 plus 2 cos theta u plus v mod square. 2 is common here, 1 plus cos theta. Now using the half angle formula, you know that cos theta by 2 equal to 1 plus cos theta over 2. From this, taking the value of 1 plus cos theta, you can write u plus v mod square equal to 2, and this 2 will be go here, 2 cos square theta by 2, because after taking square you will get this expression by removing the square root, or u plus v mod square equal to 4 cos square theta. Now taking square roots on both sides, you will get u plus v mod equal to 2 cos theta by 2, or this 2 will be go on the left hand side, 1 over 2 u plus v mod equals cos theta by 2. This is the answer. This is the expression 1 by 2 u plus v mod in terms of theta. Question number 9 will be done on the same lines like here. There you have to solve for b minus a mod. b minus a mod को आपने ऐसे ही लिखना है, b minus a dot b minus a, और इसको यूटिलाइज करके इसका सिंप्लीफाई करके आंसर निकालना है. You will get the this expression in the form of sin theta by 2. So try it yourself. Okay, in question number 7 you are given the 3 vertices of a triangle, these 3, and you have to find the vectors determined by its sides, the magnitudes, and the direction cosines. So to find the vectors determined by the sides, you will have to find AB, AC, and BC. So as you know that AB equals the difference between the position vector of O, B, and A. Now putting the values and solving it. Now see, you have to find A, B, B, C, C like this, and the expressions, the answers you will get will be. Now the second part of this question, you have to find the magnitudes of A, B, B, C, and C. Now after the taking their magnitudes, the scale of coefficients and square root, you will get AB magnitude 21, 2 units, 26 units, and square root 29 units. Now you have to find the third part, the direction cosines of this. For direction cosine, you have to use the formula AB over AB magnitude, and likewise BC over BC magnitude, and C over CA magnitude. Putting the values here, you will get the final answer. Now let's come towards question number 8. You have to find the angle between A and B if under this condition that A mod, B mod, and A minus B, the 3 magnitudes are equal. Likewise, the previous question, you can write A minus B mod square equals A minus B dot A minus B, and taking dot product, you will get form like this, and A mod square minus 2A mod B mod cos theta minus B mod square A minus B mod square. Now using the given fact that the 3 magnitudes are equal, you can write A minus B mod square as A mod square, and replacing B mod with A mod as well, minus A mod square. You will find that A mod square equals minus 2 A mod square cos of theta, and solving this, A mod square over minus 2 A mod square cos theta equal to cos theta, and cos theta equal to minus 1 by 2, and theta equal to cos inverse of minus 1 by 2. As cos is below the negative sign, you will get theta equal to 60 degrees. This is the answer. In question number 10, you have to prove 2 things. that use the scalar product to prove that the triangle with vertices, these three vertices, is a right isosceles triangle. Right means that it should make an angle of 90 degree between two vectors, and it should be isosceles. That means it's the magnitude of two sides should be same. So let's start it. You should first find the vectors made by these vertices that are AB, BC and CA using the difference. So these are the vectors defined by these vertices A, B and C. Now taking the magnitude of these three vectors, so you have to decide which side is hypotenuse, which side is perpendicular, which side is base. So after taking the magnitudes, you see that CA is the longest side, as hypotenuse is the longest side, so you can write it as AC. Okay, this is B. Now using the Pythagoras theorem here, you said that in right triangle the Pythagoras theorem is satisfied here. Now you have to prove that it is a right isosceles triangle. As you see that the magnitude of AB and BC is same, that is AB magnitude is 1 and BC magnitude is also 1, so this is isosceles triangle as the triangle has two same sides. And now to prove the second part of this question, that is it is an isosceles triangle. As you see that AB is perpendicular to BC. So if you show that the dot product of AB and BC is 0, then you can show that this is perpendicular. Now taking dot product of AB and BC equals, after taking dot product the answer is 0. It means that AB is perpendicular to BC. So from this AB magnitude equal to BC magnitude, this is 1 and this is 2. So from 1 and 2 it is proved that the triangle with vertices A, B and C is a right and isosceles triangle. In question number 11, you are given with a triangle with vertices ABC, and you have to prove that the angle cos alpha is square root 3 over 3, cos gamma is square root 6 over 3, and the angle beta should be equal to 90 degree. These three things you have to prove. Now before starting, you have to find the vertices made by these points, that is AB, BC and CA. You will take the angle alpha on vertex A, angle beta on vertex B and angle gamma on vertex C. Now you see that the angle alpha is between AB and AC. That's why you have to find AC, not CA. So after separating cos alpha from here and putting the values of dot product and its magnitudes, you will find that the answer as 18 over square root 54 and square root 18. You can write this square root 18 two times for the sake of simplification. After simplification, this will get you the answer 1 over square root 3. 1 over square root 3. Now to get the answer like this, you can write 1 over square root 3 and multiplying and divided it with square root 3, you get square root 3 or 1 over 3 square root 3. So cos alpha equals 1 over 3 square root 3. Now solving for cos gamma and beta. Now as you see that the beta is the angle between BC and AB, so after taking dot product of these two and dividing with magnitude, you will get cos beta equal to 0 and beta equal to cos inverse 0. You will get the answer beta equal to 90 degree. Also the gamma is the angle between AC and BC. So taking dot product and divided with their magnitudes, you can find that the answer will be like this. So after simplifying, you will get the answer as square root 2 over square root 3. But to match it with the book, you can see that square root 2 over square root 3, after multiplying it and dividing with square root 3, you get the answer square root 6 over 3, which is cos gamma equal to 1 by 3 square root 6, hence proved. The question number 12 requires the proof that if the sum and difference of two vectors are perpendicular to each other, that this is given that sum and difference of two vectors are perpendicular, then you have to prove that they are equal in magnitude, that the vectors will be equal in magnitude if their sum and difference are perpendicular. So let A and B be two vectors. Let A and B be two vectors, any arbitrary vectors. The sum of vectors is A plus B, and the difference is A minus B. Now as you see that given that the vectors are perpendicular, now according to given condition, sum is perpendicular to difference, so the dot product will be 0. This is given. Now to prove that the magnitude of both vectors will be same, solving this identity, the given one, A plus B dot A minus B equals 0, A dot A plus A dot B minus B dot A minus B dot B equals 0. Or you can write A mod square plus, this will be cancelled out since the dot product is commutative, minus B mod square equals 0, or A mod square equals B mod square. This will be implies that A mod equals B mod. Hence prove that under the given condition that sum and difference are perpendicular, the magnitudes of the vectors will be same. Question number 13 is asked that the resultant of two vectors A and B is perpendicular to A. This is given that the resultant of A and B, which is sum of A plus B, this is resultant, is perpendicular to A. According to this condition, if they are perpendicular, then the dot product will be 0. After solving it, you see that A dot B equal to minus A mod square. This you have to keep in mind that minus is outside the modulus value. Now you have to show that the resultant of 25A and B is perpendicular to B under this condition. Now to prove that this is perpendicular to B, you have to take the dot product of this with B, and using this condition, after taking the dot product, you find the expression like this. Now putting the value of A dot B here, this is minus A mod square plus B mod square under this condition is given 5A mod its square. Now this will be minus 25A mod square and plus 25A mod square. The answer will lead to 0. This proves that 25A plus B, that is the resultant of this, is perpendicular to B under this condition, B mod equal to 5A mod. Hence proved. So learners, this was the solution of exercise 2.1. So please like, subscribe and share my channel. Thank you so much.